Welcome to the next module. This module is on how to predict the stable ion for various elements of the periodic table. We will focus on the representative elements for this tutorial. The key to figuring these out is really the position on the periodic table. So I'll just start out here by summarizing regard to the periodic table. We can tell the number of valence electrons per column or group or family. And that goes with these A numbering system. For the 1A column, we have 1 valence electron. For the 2A column or group, we have 2 valence electrons. For 3A, way to the other side, we have 3 valence electrons. 4A, 4 valence electrons, and so on, all the way across to 8. And there we get our octet established. There is a catch to this. This A numbering system is only used in the United States, so not all periodic tables will have it. So otherwise you'll just have to count the tall columns from left to right to figure out the number of valence electrons. But otherwise it is that easy. Next we can figure out the ionic charge, which is related to the valence electrons. I won't explain it fully here because we'll learn it during the semester. So for now, just commit these charges to memory. That group 1A has a 1+ charge. Group 2A has a 2+ charge. It ends up being because those two lose electrons, as metals are prone to do. Group 3A has a 3+ charge for its most stable ion. Group 5 has a 3-, Group 6, 2-, Group 7, 1-. That is to say, all of the halogens, when they form their most stable ion, will form ions with a 1- charge. And Group A, they're the noble gases. They already have a complete octet. They are in a very stable state. They don't form ions that are more stable. So we can mark this down in our examples for argon, that it's going to have a 0 charge. It'll just be argon. What about P, phosphorus? Phosphorus is in column 5A, so it has a 3- charge, and we can write that as P superscript 3-. Sulfur right next to it to form an ionic charge will be S2-, that's sulfide, and Cl will be Cl-. Now let's add to these examples. Let's look over here at potassium. Potassium will have a 1+ charge, and calcium will have a 2+ charge. So we notice a few trends. Those on the right, those elements on the right, those nonmetals, tend to form charges with negatives, tend to form negative charges. Those elements on the left side, those are the metals, tend to form positive charged ions. Also, please notice that all of these ions are isoelectronic. That is to say, they have the same number of electrons as each other. We look at argon, it's got 18 protons, so in its neutral state, as it is shown here, we'll have 18 electrons as well. Cl has 17 protons, but a Cl- is going to have 18 electrons. So I see that all of these are isoelectronic, having 18 electrons each. And this concludes our tutorial on predicting ions and covering isoelectronic as well.